It'll make more sense once we start doing some examples. So we have 3 examples in this note, and then a flow chart, which will help you make the decisions of what to do. So in all of these cases, you should first look at if this is acute or obtuse. That's the first thing you want to look at, is that this is acute. Okay? So since this is acute, we're going to the first set of cases, of which there are 4. So you'll notice that all 4 of those, except for one, relate side length A to the height of that triangle, which is found by finding B sine A. So first we find this is acute, so therefore we need to find the height of the triangle, which is given by B sine A. B times sine A. So the height of the triangle then is B sine A. So our B value is 15. And then we're multiplying that by the sine of 16 degrees. So you just put that in your calculator and you get 4.1. Okay. So now we have to compare. So we know here, we don't know how long this length is, but we know that we have an angle here of 16 degrees. And this side length here is 15. And the A has to be across from angle A, right? Because of labeling. This is 3 meters. Okay? We just found that this height is 4.1. So therefore, since 3 is less than 4.1, that means that A is less than the height. Okay? So A is less than B sine A. So therefore, there's no triangle. Okay, there's no triangle possible because this isn't long enough to reach this side, given that this angle is 16 and this length is 15. We found that this height using SOHCAHTOA has to be 4.1. So that's the smallest that this can be, that this A can be to create a triangle. So since it's less than that, no triangle is possible. We're done that question. We can't go any further. Okay, now you'll notice in this question, it doesn't use ABC, and I did that on purpose because it won't always in your textbook either, so you have to really think about labeling it. Okay, look, you're given angle S, side S, and side T. Remember that side S is the one across from this given angle. So, we always want to start drawing these with our unknown side length there. You can just draw a long line. Okay, our known angle, we're always going to draw it here. And in this case, it's 130. So I should actually draw it as an obtuse angle. So this is 130 degrees. It's our known angle. Okay, and this side length here is 20. I can't use 50, because remember the 50 has to be across from S. So this is going to be the T value, so that's 20. And then it's saying that S is 50 long. So my S here then is 50. So we have to see if this is possible. So angle S is obtuse. So therefore we go to our set of cases, so you can go back in your note. When the angle is obtuse, you have 2 options. Either A is greater than B or A is less than B. So remember, A, when they talk about A, they mean the angle across, the side length across from the given angle. So they mean 50. So in this case, 50 is greater than 20. So that means A is greater than B. Because A always refers to the side length across from the given angle, and B is the side length given that's not across from the angle. So if you go back to your note, you'll see, oh, A greater than B means that there's one obtuse triangle. So now I need to solve this triangle. So I drew it. So now I need to solve the triangle, which means come up with this side length and these 2 angle sizes. So I can just use sine law. So I will start by solving for angle, so this is S, and then this has to be T, because this was little t, and I'll assume this is R, RST. So I'll start by finding angle T. So find angle T. So I can use the sine law. So I'll set up sine T over little t. So that's 20. equals sine of 130 degrees over 50. Okay? So then I rearrange this, I get sine t equals 20 times sine 130 over 50. You put this in your calculator, you get some number, then you take the inverse of that number, and you get t is equal to 17.84 degrees. Okay? So then I know this is 17, so I'll round that up to 18 degrees. So then I can find angle R using the fact that they must all add up to 180. So that angle R will equal 180 minus 130 minus 18. So that will equal 32 degrees. Okay, so now the only thing I need to find is this side length R. So again, I can use the sine law. So side length R over sine 32 degrees. Okay, I'm just using the sine law. And then I can choose either one of these known ratios. I'll choose the one that was given. So then 50 over sine 130. Okay, I rearrange, I solve, I get 34.7 meters, which would round to approximately 35 meters. So notice that when I'm doing the sine law, I always set it up so that the unknown part is in the top left. Okay, so in this case I used sine over side length, whereas this case I used side length over sine because that was what was unknown. So it's easiest to set it up that way just so you don't mess up algebraically. So there you go. Now I know all parts of the triangle. I know that this is 35 approximately. Okay, this is 18 degrees and this is 32 degrees. So I solved the triangle. I found the other three pieces of information that I didn't know. Okay? Okay, now let's get to the big stuff here. All right, so in triangle ABC, you give an angle A, it's acute, that's the first thing I notice. Okay, side A and side B, so I'm given an angle, a side, and a side, so I know I can't just go ahead and do the sine law. I have to actually do some checking. So I'm not given this long side length. I always draw my known angle here, okay? Always draw it in the bottom left like this. So this is 40 degrees, and it's angle A, we're given that. Okay, we know that this is side length B. It can't be side length A because A is always across from angle A. So this is 27 long. So now the problem is that we're given A is 22 centimeters. So we first want to check, is that the same as the height of a triangle, or is it smaller than the height of that triangle? Because then we can just make some conclusions. So remember that the height is just equal to B sine A, which in this case is 27 times sine of 40 degrees, which is equal to 17.36. Okay, so you'll notice that our A, the given A, is greater than the height. Okay, so that means that either we have one obtuse triangle or we have the ambiguous case with two triangles. Okay, so now we look at A compared to B. So A is 22, so A is less than B. So that means A is less than B but greater than height. Okay, which is B sine A. So therefore there are two triangles. Oh no, we're sad because now that means we have to do a lot of work. All right, there's two triangles possible. So we need to actually solve for both triangles. Okay, so the first triangle, we're going to draw them both. So here's triangle 1 and triangle 2. Okay, the first triangle here, we have 40. We're going to do the acute one first. Okay, we assume that this is 40. We're given that this is 40. Sorry, we don't have to assume that. We're given that this is 27, and this is 22, and we're assuming that it meets here. at an acute angle. Okay, so we'll label that B1, and we'll label this C1. So now you can just go about your normal life using the sine law to figure everything out. Okay, we can find angle B using the sine law. So sine of B1 over the length 27, its opposite length, equals the sine of 40 degrees divided by 22. Okay, so you use your calculator and you find out that B1 is equal to 52 degrees. Yay! You can label that in. I'm going to use different colors. Okay, so now since we know that's 52 degrees, we can find the length of C1, the size of C1, just using the fact that these all have to add up to 180. So C1 is equal to 180 minus 40 minus 52. So it equals 88 degrees. So C1 is equal to 88 degrees. Okay, so the only thing we have to find now is the length of C. So you can use your newfound 88 degrees and the sine law to figure that out. So length C over sine of 88 degrees equals 22 over sine 40 degrees. So use your calculator, blah, 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 you get that C is equal to 34 centimeters. Okay, make sure that you are using your calculator properly and actually getting these numbers. So this is 34 long, and voila, I've solved my triangle. I have all three side lengths and all three angles. So that was just the first case. The second case is that I have my angle length 40. This is 27, so this so far should be the exact same as I drew before, but my length of 22 is actually hitting here, so this isn't drawn. So this is 22, but it's creating an obtuse angle for B1 and then a quite smaller angle for B2 and C2. So you might be thinking, but Mrs. Means, we already found that B is equal to 52 degrees using the sine law. So if I use the sine law again, I'm going to get 52 degrees again. Well, you're right. If you just use the sine law again, you will get 52 degrees again. So that's why you have to use the fact that B1 and B2 add up to 180. Because remember, if you don't understand that, go back to the picture. It creates that straight line because it's an isosceles triangle. So I just need to use the fact that B1 and B2 equal 180. So therefore, B1 is 52 degrees plus B2 equals 180 degrees. So angle B2 is equal to 128 degrees. Okay, so we can label this 128. Okay, so now we need to find C2. So C2, we can just use the fact that 40 plus 128 plus C2 have to equal 180 because it's a triangle. So then C2 is 12 degrees. And then we can use sine law as before to find the length of C, and you'll get 7.1 centimeters, okay? Using that this is 12 degrees now, and using the sine law. So C over sine 12 equals 22 over sine 40. That's what you'd use to find the 7.1. So here you go. We're given in triangle ABC these three pieces of information. Angle, side, side. It's that awful case we don't like. We did a little bit of work to see, well, is it just one right triangle? Is it one obtuse triangle? Or is it just no triangle possible? But the work told us actually it's the one case where there's two triangles possible, because this side length opposite the node angle is greater than the height that would be if it were a right triangle, but it's less than the length of this side, B. So therefore, it could join up here, or it could join up here. So I have to present both cases because we don't know which one is right. So we have to present both triangles. Okay, so I understand that this is a lot of information to take in. So I do have, oops, I gotta erase that. this for you. And instead of, I'm going to go through it semi-quickly, but you can pause the video to make sure you get it all copied. Okay, because you actually are going to be able to use this on the test, this paper. Okay?